today we're going to look at how to solve a system of linear equations by using a method called elimination. So to use elimination, the first thing you're going to have to do is make the decision about what variable you would like to eliminate from your problem. So this method works best when your equations are in standard form, both of them, and we're going to choose one of these two variables that we would like to eliminate. So I personally am probably going to choose the 3x and the 5x. There's nothing wrong with choosing the 7 and the 2y. So to do that though, I like to do my elimination by adding both equations together every time. So what I do is when I change my coefficients, I make them into opposites of one another. So I incorporate that as I change my coefficients. So if I'm choosing to get rid of the 3 and the 5x here, I will need a number that I can make both of these into by multiplying my equations by a constant. So I'm going to choose 15, and so that requires me to multiply my top equation by 5. Now that's going to give me a new equation of 15x plus 35y equals 75. I'm taking everything in that first equation times 5 if I want to change that. And then the bottom equation, so that I end up with opposites, I need a negative 15, which means I'll need to multiply by negative 3. So when I multiply that entire equation, I get negative 15x minus 6y equals positive 12. And then I'm ready to go to the next step, which is to add the two equations together. And so when I add the two equations together, I simply just add the x's together, add the y's together, add the constants together over here. So 15x plus a negative 15x gives me the 0. That's where the variable eliminates. 35y, a positive 35y, and a negative 6y are going to give me a positive 29y. And then 75 plus 12 over here will give me a positive 87. And you can see once I finish eliminating that one variable, now I'm down to just a single equation with one variable. And I'm going to finish by solving 29y equals 87. And that requires me to divide by 29. And I get y equals 3. Okay, and so just like our previous method of substitution, once you find one of your values, you're going to take that value, go back up here to either of your original equations, we'll plug that in, and we'll figure out what it is that we need to use for x. Okay, so I'm just going to use this top equation right here. So we do 3x plus 7 times 3, put the value we just found in there, equals 15. So 3x plus 21 equals 15. And then I'm going to get 3x equals 15 minus 21, and we'll get negative 6, divide by the 3, and I get that x equals negative 2. Okay, so again, now I'm solving this system by using elimination, but it's still an ordered pair for x and y that I'm finding for my solution. So my solution to this is the ordered pair negative 2, 3. Make sure you put them in the correct order, x, y, regardless of how you found them when you did your elimination.